Hello everyone, this is day 13, question 1 of our Leetcode activity, which is word pattern. So this question is similar to the question we solved earlier, isomorphic strings. So how is it similar? So given a pattern and string S, find if S follows the same pattern. Here follow means full match such that there is a bijection between a letter in pattern and a non-empty word in S. And specifically, each letter in pattern maps to exactly one unique word in S. Each unique word in S maps to exactly one letter in pattern. No two letters map to other words to the same word, and no two words map to the same letter. So here you can see A B B A. This is our pattern. M is mapped to dog and B is mapped to cat. So A B B A should be dog, cat, cat, dog. A B B A dog, cat, cat, dog. So this follows the pattern. So we return true. Now here is mapped to dog, B is mapped to cat. So A B B A should be dog, cat, cat, dog. But here it is dog, cat, cat, fish. Now fish is also mapped to A, but no two letter can be mapped to same word or no two words mapped to the same letter. So this does not follow the condition, does not satisfy the condition, so we return false. And this is obviously false as A now firstly A is mapped to dog. Now again A is mapped to cat. So this also violates our condition. So this is returned false. So some important constraints that we need to see are S contains only English letters and spaces. Good. S does not contain any leading or trailing spaces. This is also important. And all words in S are separated by single space. Very nice. So now, why these three conditions are important? These three conditions will help us write this logic. This logic as firstly it said it only contains English letters, lowercase English letter and spaces. So there is no numerical or special character that we need to care about. We only care about letters and spaces. Now does not contain leading or trailing spaces. So here we don't need a logic to firstly skip the leading spaces or the trailing spaces. So our logic has become simple and all words in it are separated by single space. So whenever we see a single space, we can directly mark the word completed. So how we will do this? How we will use that conditions? First we declare a vector of strings words, and we can declare a temporary variable string current. Now for character seen as, firstly, if the word is our correct character is a space, we'll skip this logic for now. Let us go to else. So now if it is not a space, then there were just two options, a lowercase English letter or space. So now if it is not a space, then it is a part of a word, a letter of a word. So we add that to our current string current word. So now we will add these letters to our current word until and unless we see a space. And when we see a space, what does that mean? So here you can see firstly dog. So what will happen in our algorithm? Firstly, D will be added to current, then O will be added, then G will be added. Now it will see a space. Now space means that this word is completed. So now the word is completed, so we'll push back our word current in the current word in the string words, and again mark the current empty, so that we can now add the second word. And again when we see this white space, we add that word to the string, a vector of string word. In such a way, we can get a vector whose indexes map to the words. And why are we doing this? We are doing this so that we can map this pattern to our given our vector of words and check the pattern if it follows the pattern or it does not follow the pattern. So we do this, and then again after all the for loop is completed, you can see the last letter doesn't have any uh, trailing or leading spaces. So here there is no space. So if there is no space, the last word will be just stored in current and it won't be added. So for that, we after the for loop, we run this command words dot pushback current, as this is the last word we have to add it. Now the most simple logic, first we have to check if pattern dot size equal to word dot size. That word dot size will give number of elements in words in vector. So number of elements in vector will be number of words, and pattern size will give us the number of letters in the string pattern. So if these both sizes are different, then of course word does not follow the pattern, so we directly return false. Now we get to the next logic of the question. Now we check if, now that we have the vector words and the pattern string, we can compare them. Declare an unordered map of char string and then unordered map of string char. Now character to string, where the key value is character and the value is string, mp1, this will be matching the pattern to words, and this which is string to character, this will mp2, this will match our words to the letters. Why we need to? Because we have to check both ways. Each letter in pattern maps to exactly one unique word in S, and each unique word in S exactly maps to one letter in pattern. So for int I less than pattern dot size I plus plus, character ch in pattern I. So the character in pattern I and string word in words. So these both indexes are same, so we are checking the equivalent indexes for both. If mp1 dot count ch and mp1 ch not equal to 1, return false. That is either mp1 count ch, that ch does not exist in the map yet, and mp1ch not equal to word. So if, so this is and, so this should be one, this should be, both should be one to return false. So if ch exists in the map and it does not associate to the word, so at the add position and the add position, so like here you can see, so after this all conditions we are lastly assigning msch word and mp2 word to ch. So now how, see here, in the first thing a does not exist, so a will be associated to dog, and also dog will be associated to a. So when we do this for b and get on to the last a, so now a will exist in the map, but a will be associated to dog, but what it will check at the last condition will be pattern and word size. So word size will be fish, so a will not be associated with fish, so we will return false, like a exists and it is not associated with the current word, so that means it is already associated with some other word earlier and it cannot map to two at once, so this is false. And same for word, that some word has already been associated to some other letter, and now this is a new letter which is trying to associate with this word, so two letters cannot associate with one word, so we return false. And if these both are not true, so either it means that our letter does not exist in the map or our word does not exist in the map, or whatever the current word is, it associates with that word itself. So for the first condition, that letter or the word does not exist in the map, we add those to the map and again run this for loop for the entire pattern string. And after all this loop is run, if we find no condition where our maps, these both conditions are satisfied and we return false, which means there is no mismatch in both the maps after running all the loop, that means there is a one-to-one association of letters to words and words to letter, and we return true at the end. So this is the logic. And if we actually go for the time complexity, for this is O of n, and we are doing this for character in s, so this will be the, what you can say, the O of s dot length, and these next part are not nested, so this will be O of n plus. Now here we are first of all doing a for loop for pattern dot size, and internally we are also using map. Now map itself, to add a, or to add or to retrieve or to check, it uses log n type, as internally it uses red black tree structure, which is self adjusting structure, and its implementation uses log n time. So this is n and this is log n. So this will be n plus n log n, that is ultimately n log n time complexity. And the constraint given is pattern dot length is 300. Pattern dot length is 300, and here n will be strings. So 300 log 3000, it's not, it is very possible in our time limit. So this is a good optimal approach for the question word pattern. Thank you.